Hi, in today's video we have something interesting. Here at the shop I have two vintage NuTone Intercom master stations, and both of them are tube-based models, not solid-state models. This is a model 2055-2056, and this is a model 2051-2054. The reason that they each have two model numbers associated with them has to do with the way NuTone labeled models back in those days. The 2055 and 2056, one is the copper toned master station, the other one would have been silver. Same thing with the 2051-2054. One is a copper, this is called copper tone because it's painted, and then there was also a silver one. So they used to give different model numbers to master stations with different finishes, and that's why we have so many different model numbers. They are always essentially the same chassis, just a different faceplate. The 2055-2056 was a nearer the top model compared to the 2051-2054. This is really would have been the builder entry level model of the day. I've done a quite extensive video on rebuilding a 2055-2056, and there's also a pretty good write-up on the website, which I'll link in down below in the comments. Today we're going to pretty much focus on the 2051-2054. So let's go ahead and move this one out of the way and take a look at what we have here. So here we have our 2051-2054, and as I said, this was the builder entry-level intercom system back in the day. Both of these intercoms are early 60s. The 2055-2056 is code dated as 1964, and although this one doesn't have a code date that I could find stamped on the chassis anywhere, I'm going to show you how you can determine approximately when it was made. Since this is an entry-level model, you will notice that it's an AM radio only model. There's no FM on this. It's just AM with built-in intercom. You do have a selector switch here where you can switch it from between radio and intercom, and then also there's a phono input so you could connect a phonograph to it back in the day. You have a rather unusual setup here where you have your master speaker volume adjustment is this 3-position slide switch. You can put it in the center and that turns the master speaker off altogether, or you can set it to a low volume or a high volume. I guess they didn't want to put it in another volume control that would have cost more money, whereas the slide switch was probably inexpensive. You have your radio tuning here, and then your on-off switch and volume. This would be, in today's world, it would be system volume, where it adjusts to the maximum level that any of the remote speakers can play at. And then your switchboard assembly fits through these slots. It'll be mounted on the back side of the master, and it's part of the wall housing on this model. So you have a fairly simple faceplate design. It is metal, it's not plastic. You have these punched louvers here, and then it has what NuTone used to call a copper tone finish, which is painted, and it's sort of a variegated, it's lighter here, and then as you move up towards the edge is actually darker than the center part, so it gives it a little more dramatic look, I guess. So it's a kind of an interesting model. I thought I would show you what it takes to start repairing one of these, because tube-based models, because we don't get as many of them in nowadays as we used to, they require a little more upfront effort before you can actually start repairing them. So let's go ahead and turn it around and do sort of a review of what's on the back side. So on the back side of the set, this is the area where the switchboard and terminal block assembly would be mounted. It's part of the wall housing, and these wires, this red and black and green and black over here, these attach to screws on the back of the switch block assembly. This portion of the chassis is the power supply section. You'll notice on a lot of these early 60s models, it's a single circuit board design. This is one long circuit board. It's mounted to the metal chassis. Unlike higher end consumer tube-based audio equipment, which would still have a lot of point-to-point wiring and things like that to ease manufacturing, and that's code talk for keeping the price low. Everything's mounted on a single circuit board. So the 2051-2054 has vacuum tubes in it. There are 5, so there's 1, 2, 3, 4, 5 vacuum tubes. The 2055-2056 has 6 vacuum tubes because you need an extra one because it's an AM/FM model. Since this is only AM, it only has the 5. Speaker is here. All tube-based NuTone models use 3.2 ohm speaker cones. This blue wire here, this is where the AM antenna wire connects. You have the AM tuning, either you can call it a variable capacitor or a variable condenser, depending on what school you went to. This is the power connection here. All NuTone tube-based models have, this is a safety interconnect design, which means that when you remove the screws and pull the faceplate away from the wall, it automatically unplugs from the high voltage socket that's part of the wall housing so you don't get a shock. One of the things I should point out is if you're considering trying or attempting to work on your own tube-based NuTone intercom system, you have to understand that tube-based equipment has as part of the circuit, there are potentially lethal high voltages in this set. That's why you have the safety interconnect. So in theory, an untrained or unknowing person isn't poking around with a screwdriver while it's powered up. There is enough voltage in here that it can seriously hurt you. So if you don't know what you're doing and you're not familiar with working on tube-based equipment, keep your hands out of it because you don't have any business touching it. So let's go ahead and take a quick look at some of the interesting parts of what I see here, and then I'll show you how you get started on a set like this. One of the first things you'll notice when you open up a set like this is how dirty and dusty it is inside. It's not uncommon to find them like this, and although you may think, well, that's really bad, actually from my point of view, it's actually really good because it means that perhaps to a large extent this set has been untouched since the day it was put in. I know that's not necessarily the case with this particular one, and I'll show you how I know that in a minute. One of the things is everything on the circuit board is labeled. Everything has part numbers. Here we have L2 and L3. It's a little hard to read because of all the dust, so if you take a small bristle brush and you brush it away just a little bit, you can uncover the labeling, and cleaning the set carefully is actually the very first step that you perform when you're going to work on one of these. And now that we've cleaned away some of the dust, we can see perhaps that this tube right here is a 12BE6, which is a fairly common radio tube in the world. And over here we have a 12BA6 and so forth. So it identifies what all the parts are. So right here we're looking at the variable condenser or variable capacitor that's the heart of the AM tuner. And like everything else on the back of the chassis, it's covered full of dirt and dust. So if we brush this away a little bit, you'll see that it comes off fairly easily. But one of the problems with this type of design is if we open this up a little more, you'll see here, in fact, let me do this. So a variable capacitor or variable condenser is a design where you have all of these thin metal fins, and they're all held in place as part of the assembly. And here, these fins are fixed and they go down inside where you can't really see, and these fins actually move as you turn the knob. They open or close. This one doesn't want to turn very freely, so we'll give it a little help. And what's happening when you do this is the fins are folding in between each other, and that's how the tuning is actually accomplished. One of the problems with older sets like this is the tuning doesn't work well when the fins are full of dust. And this one obviously is. If we just brush them lightly, a lot of it just falls away, which is good. As a caution, you never, ever, ever spray anything on the tuning capacitor. Not ever. If you get any kind of liquid, and when I'm talking about spraying it, I'm talking about contact cleaner or lubricant or silicone or everyone's favorite WD-40, I absolutely will guarantee you that if you do that, you will ruin it and your set will never play the radio again. So don't do it. The only thing you ever do is you brush it lightly, and you can use compressed air carefully to clear it out. You never ever spray anything on it. And yes, we do get sets in fairly often, maybe 4 or 5 times a year, which is a lot for tube-based models, where people go to town with the spray cleaner and they think, well, I'll just spray everything and it'll be better, and then their radio won't work. So you cannot do that. You never spray anything in it. You simply move it around, brush it lightly, and then you can hit it up with a little compressed air. And that will do wonders. Another technique which I like, which I've seen people do, is a lot of people will take a feather, like the kind you pluck off a bird, and you can very carefully take the feather and run it through the gap between the fins. You absolutely do not want to bend the fins in any way. You need something that will lightly brush the dust away, and a feather seems to work pretty well. So that's a proper way to go about it. Let's go ahead and take a look at the vacuum tubes now, and I'll show you what they can tell us. So first we're going to look at this. We're going to use this as our example. This is the 12BE6, and vacuum tubes are almost always mounted in a plastic socket in NuTone intercoms, and to remove this, you very carefully grab the glass enclosure and you wiggle it and pull it up, and it unplugs. And here's the socket that it was mounted in. And let's go ahead and take a close-up look at the tube. So here we have our 12BE6 vacuum tube, and I hope you can see on the video, you have this orange marking on the outside of the glass envelope, and actually this says NuTone on it. This is an original tube from when the set was made. Most NuTone tubes were made by RCA, and they're private labeled as it says NuTone on it, because if you buy enough tubes you can have that done back in those days. And so this is an original tube, and if you turn it around this way, it's a little hard to see, but right here printed on the tube it says 12BE6, and underneath it says USA, because back in the 60s vacuum tubes were manufactured in the United States. That's not the case anymore. Most vacuum tubes nowadays are manufactured in Eastern Europe or Russia, so you won't find any US made tubes, not any new ones anymore. And one of the things the tube can tell us is if we turn it around, here it says in orange made in USA, and it has a manufacturing number, which is 323, and then the important bit is it says 6344. That tells me that this tube was manufactured in the 44th week of 1963. So that's near the end of 63, so that would date this intercom probably sometime in the early 1964. And if you think about it for a second, if this was made in 1964, it is now 52 years old. If this tube is good, which we're going to check in a minute, it would have lasted 52 years, which is a pretty good value. Back in 1964, I would imagine a tube like this would probably have cost somewhere between maybe 50 and 75 cents. So it wasn't a lot of money, so you get good value on vacuum tubes. If we look at some of the other tubes, we can take this one out. This is the 12BA6. And here it says 12BA6 on the tube, and it says England, which I assume is where it's made. And if we turn it around, it says Realistic on it. Realistic was the brand name that Radio Shack used on their tubes, and back in those days, or maybe even still today, I'm not sure, Radio Shack or Realistic tubes had lifetime guarantees. Maybe if this is bad, I'll take it into our remaining local Radio Shack store and see if they'll give me a new one for free. Here we have another Realistic tube. It's a 50C5, which is a rectifier tube. So we'll put that one over here. Here we have a 12AX7. This is a preamp tube. 12AX7s are used as preamp tubes in almost all sorts of audio equipment. It's the sought after basic tube design for preamps and almost anything that's audio based. 12AX7s have a certain aura about them. It's the kind of tubes that audiophiles and tube fanatics search out for. There are certain special ones that give the sound a different meaningfulness to them, and they're always looking for those ultra rare tubes to put in their home audio equipment. This is probably, since it came from Radio Shack, again, it's probably more one of the run-of-the-mill versions, and what the audiophiles are generally looking for are those ultra rare German-made Telefunken, the ones with the black plates inside with the 3 grooves and the special little holes that give the sound of their amplifier that warm fuzzy feeling that everybody thinks is so special. That may be fine if you have a real high-end piece of tube equipment in your home stereo setup. For NuTone intercoms, it's not so important. So we take that one out, and then way over here on the end where you can't see, here we have another one. This is a 35W4. No label on this one, so I don't know where it came from. It could be an original one from when the set was new and the markings have worn off. That's one of the things that happens on these. If I take this genuine NuTone tube here with the orange markings on it, if I were to wet my finger and go like this, the orange marking would just rub right off because it's so old. So lots of times the markings are missing. So we've taken all the tubes out. We'll set those aside for a second. And let's take a look at what else we have here. So contrary to what a lot of people may think, a lot of the problems with tube-based equipment nowadays is not just the vacuum tubes. That may have been true when this set was 20 years old or 25 years old. Vacuum tubes can wear out depending on where they're placed in the set and the job that they're doing. But those normal type of failures really get pushed by the wayside when you're talking about a piece of equipment that's 50 years old. And a great deal of the problems with these sets that we see when they come in have to do with supporting components. A lot of that, the initial thing, are always capacitors. For instance, this is a multi-section capacitor in the power supply. This is not of the highest quality because instead of it being in an aluminum enclosure, it's in basically a cardboard enclosure. It looks like it was made by General Instrument Corporation, so don't know who they are, don't know what the quality is, but probably not the top quality. This definitely will have to be replaced. And then there are a variety of other electrolytic capacitors. There's one here, there's one here, there's one buried down underneath here. These are also all General Instrument Corporation parts. And back in the 60s, this type of part, these are epoxy capacitors. They have epoxy bodies, and what happens to these over time is they just fail due to age, and the enclosure, the epoxy capsule that holds everything together, they become porous and susceptible to moisture. So that can be a problem, especially when it's mounted in a wall cavity. So all of those will have to be replaced. There are no solid state parts in this. There are no transistors, there are no diodes, anything like that. It's all discrete components. There are a variety of ceramic capacitors, which generally are not much of a problem. There may be a couple film capacitors. I'll have to check and see. And then there's a variety of resistors. On sets like this, every single part has to be checked. Parts will drift out of specification as they get older, especially resistors in tube-based equipment. So all of those have to be checked, and anything that's out of spec should be replaced. Okay, so once you've had a good look over of the tube-based NuTone intercom system that you're going to be repairing, and you've cleaned it up a little bit, and you removed the tubes from the chassis, now it's time to do one of the fun parts, which is we're going to check the tubes and see which ones are good and which ones are bad. So these are the tubes I took out of the set. We'll put those off to the side, and if you're fortunate, you've got yourself one of these. This is my Sencor TC142 tube checker. And I'll go ahead and open this up. And what this is this is a portable serviceman's tube tester. This particular one belonged to my great uncle, who lived in Omaha, Nebraska, and back in the 40s, 50s, and 60s, he was the local radio repair guy. He had a radio repair shop in Omaha, Nebraska, and I think this is vintage early 60s. And this is the tube tester that he would take out with him, or perhaps one of his guys would take out with him when he would go to people's houses to work on their console radios and later on television sets, because he did transition into televisions when those came out also. When he retired and closed the business and moved into a retirement home, he sent me a lot of his test equipment that he had, because he always says that I'm the only one in the family that got any of his genes and is interested in fixing things. So having a tube tester is a handy thing, because finding local tube testers that are available for the public to use, at least in this area, is hard to find. So let me show you a little bit about how this works. Okay, so with every tube tester, whether it's your own that is a portable model, or if it's a public tube tester, there'll be a booklet. Or if it's a public tube tester, like when I was a kid, we used to go down to the Coast to Coast Hardware, and up in the front of the store buy the firewood and the cigarettes and those kind of things. They had a console tube tester. It was sitting on the floor, and it would have these big reels, and you would turn the knobs and the reels would go around and around and around, so you could look up the tube that you needed to test, because it tells you some important information. So here in my Sencor, it's a Mighty Mite. In fact, it's a Mighty Mite 5, and America's most popular tube tester, fast, accurate. It never lets you down, and I would have to say that that's probably true. I don't think I've ever had a problem with using this. Steel construction, only weighs 7 pounds. New low voltage checks for NuVistors. NuVistors were a device that was sort of a bridging device between conventional electron tubes and transistors. So that was in the 50s, I think. They were very short-lived. It gives you basic operating instructions, but the important part of this is the information in the booklet. So if you leaf through it, you'll see that it lists all sorts of models of tubes, and there's page after page after page after page of them. And I know with some companies, and maybe Sencor was one of those kind of companies, if you bought a tube tester, you could also get a subscription with the company, and periodically they would send you an updated booklet or updated rolls if it was a big tube tester, to keep up with all of the modern new designed tubes that had come out since you bought the last booklet or when you bought your tester. So what you have to do is you have to look up the tube in the booklet that you want to test. So the first one we're going to test is this. This is a 50C5. This is the power tube in the intercom, and I chose this one. This is an original NuTone tube. It says 52nd week of 1963 when it was made, so it's 53 years old. And I chose this one because this one is very likely to be bad. So let's look this up first. So this is a 50C5, so the first is a 50. So we'll flip open to the right section. And here are 50s, and we'll find 50C, where is it? 50C5 right there, right between 50BM8 and 50C6. So what this tells us is basic settings for the controls on the tube tester. A is set to 50, B is set to C, C control is set to 5, D is set to B, and it fits in socket number 4. So we'll go ahead and put the little holder there to keep the page open, and let's go ahead and test a tube. Okay, so here's what we're going to do. The booklet says the tube fits in socket 4, so we'll go ahead and plug it into socket number 4. And now we need to set the controls to match the information that's in the booklet. So control 5 is set to 50. This is 39 to 50. Control B is set to C. Control C is set to 5. And D will be set to 4. So now we have the controls set to match the information in the booklet. and we're just going to simply turn it on. So this is the control knob. It's in the off position right now, and we're going to turn it to emissions, which is the first test. And now we're going to wait. One of the things about electron tubes is they have to warm up. It's not like solid state components that come on instantly. Tubes have to warm up. And you could see how the needle swung from below 0 to the right, and as the tube stabilizes, the needle should stop moving, and it looks like it's just a hair under 100 in the good range. So they give you sort of good parameters here. It would be -10 up through about 50 is bad. Between 50 and 70 it's questionable, and 70 up to 120 it's considered to be good. So this one actually tests as a good tube, at least for this particular test. Now the next test we're going to do is what's called grid leakage, and that's the second scale here, which you'll notice is backwards of the other scale. We have bad for emissions but good for grid, and the same here. So we'll go ahead and switch it over to grid leakage and see what we get. Whoops. So if the tube was good, the needle would have swung to the left and it would have landed somewhere in the good range, but here it's stuck in the bad range, so this tube is actually no good. It has a leaky grid, and that means that it has to be replaced. There is also a short test, which if you move it to short, and then what you do is you rotate the setup knob while you watch the short indicator here. And if we flip it, we go through each one. So we're at A, then B, C, D, E, F, and so forth. And if there was a short, as there shows now, so it shows a short on H and K. And sometimes in the booklet, if there's an acceptable short, for instance, it'll show an asterisk and it'll say disregard all shorts except for, and then it'll give you the letters. There is no notation for the 50C5, so it has a short between H and K, which is probably why it's no good. So we'll go ahead and go back to this, to grid leakage, which is still bad. The emissions is good, but the grid has failed, so this tube is shot. So that's sort of the fundamentals of testing electron or vacuum tubes. You have to go through each one and test it to see if it's good or not, and then compile a list, and it'll become part of what we're going to order from the supplier for tubes and other components to fix the intercom. I hope you found this video to be interesting and perhaps helpful. If you did, please give it a big thumbs up on YouTube. We would appreciate it if you would subscribe to our YouTube channel.